All right, there we go. Great. Okay, so each year, the Geography and Earth Sciences junior faculty host a free speaker series to highlight all stages of researchers with work spanning many disciplines, degrees, and interests that comprise the department, including, but not limited to, urban and regional planning, ecology, meteorology, climate modeling, hydrologic sciences, food and human geographies, and socio-ecological system science. This year, the GES Speaker Series highlights scholars and researchers whose work engages with or has connections to environmental justice, community planning and engagement, and social environmental interactions. Today's event marks the kickoff for the series, so thank you all for being here. And it is also being co-hosted by the Center for Applied Geographic Information Science, or CAGIS, as they're called. And they are an interdisciplinary research center that focuses on using advanced space-time theories, methods, and technologies in cutting-edge geographic information science to address pressing multi-scale resource and sustainability issues. So with that, I would like to introduce Doug Shoemaker, who is the Director of Research and Outreach, and he will be introducing our speaker for today.
Thank you, Dr. Hoover. I'd like to start with this introduction by talking a bit about urban forestry in Charlotte. In 2019, I worked on a series of articles bringing attention to the fact that despite having a tree canopy goal of about 50%, Charlotte had actually cut down 250,000 trees over the 6 years after the Great Recession, or about 3 football fields of tree canopy per day. Okay, the loss of those trees meant that Charlotte was hotter, our air and water less clean than before, and our residents more vulnerable to the impacts of climate change. However, underneath that story of canopy loss was another story about how communities of colors didn't get to share in the benefits of trees because they didn't have that many to start with. On August 28th, 2020, our local NPR affiliate ran a story entitled "Charlotte's Declining Tree Canopy Hides Years of Loss in Historically Black Neighborhoods," showing how Charlotte's underserved and overburdened neighborhoods lacked access to the green amenities that trees provide compared to more advantaged neighborhoods. But it's not just Charlotte with this problem. It turns out that many of these disparities or environmental injustices have occurred and continue to occur in many US cities, and we know this because of the ever-expanding body of research generated by today's speaker, Dr. Dexter Locke, and through collaborations with his extended research team. Dr. Locke is a self-described urban ecologist working as a research social scientist at the Forest Service's Baltimore Field Station. Dr. Locke earned his bachelor's from the University of Vermont in 2009, and his master's in environmental science from Yale in 2013, and his PhD from Clark University in 2017. Along the way, Dexter worked for the New York City Department of Parks and Recreation, as well as a Forest Service program called People and Their Environments, Social Science Supporting Natural Resource Management and Policy. Our own Dr. Hoover and Dr. Locke got to know each other when they were both postdoctoral fellows at CSANC, the National Socio-Environmental Synthesis Center in Annapolis, Maryland. In his comparatively brief career, Dr. Locke has already authored and co-authored over 60 peer-reviewed articles. Today, Dr. Locke will present Urban Forestry and Environmental Injustice, Past, Present, and Future. Take it away, Dr. Locke.
Many thanks for that kind and thorough introduction. Can you see my presentation?
Yes.
Great. Thanks so much. I think that's absolutely fantastic context with Charlotte and tree canopy. Often Charlotte is looked upon as having a really high tree canopy cover, and tree canopy change is really a frontier in this space. And the story in Charlotte, unfortunately, is common in many other cities. So that's a really great background and context. So as mentioned, I'm Dexter Locke, research social scientist with the Forest Service. And as I put this talk together, I just want to say how grateful I am. It's a real privilege to be jointly hosted by the Department of Geography and Earth Sciences. As mentioned, I did my PhD in the geography department, as well as CAGES. And given the broad and diverse interests, I hope there's something for everybody in this talk. So thanks again for hosting me. So trees provide many benefits or ecosystem services in urban areas, in forested climates. So in places that in the absence of humans, these would be forested places, trees are really important. So as we start removing trees and adding roads and buildings and other infrastructure, we lose those benefits. And when we add trees, as mentioned, it's cooler in the summer. We can remove impervious surfaces to help improve water. Dr. Hoover's done some important work there. This is from the Nature Conservancy, which has a growing footprint in urban areas. They're also talking about increasing property values, which might actually be a disservice in some communities. So we can talk more about that. But the role of trees, and here's another look at it from an organization called Speak for the Trees in the greater Boston region. They're sort of these great multitaskers, providing a suite of environmental and social benefits in forested biomes. And so in response to that, here's the bandwagon. Many municipalities have jumped on the bandwagon, have ambitious urban forestry goals. This slide's a little bit outdated. New York City has completed their Million Trees initiative and is discussing a second million. Not pictured here, Houston is talking about 4 million trees in their metro region. So many municipalities have a STEM goal, like New Haven, 10,000 or million trees. But some municipalities have opted for a canopy goal as well. Washington, D.C. has a 40% goal. Baltimore, where I'm located, has a 40% goal. Philadelphia wants 30% per neighborhood. So it's a little bit more spread out. You can't just bank on having all your tree canopy in some of these regional parks. So there's a lot of management interest in trees from sustainability plans, comprehensive plans, all kinds of regional documents. And it affects a lot of departments and a lot of non-governmental agencies as well. So I'm putting my talk together. Maybe this is a little bit cliche, past, present, and future. But I want to highlight some research some of my team has done on redlining that might help explain some of the disparities we see today. And then since I don't have a crystal ball, future is of course speculation, but I think there are some indicators we can look, especially since trees are fundamentally slow growing organisms. Also, when they come down, they're coming down big. And when we put them in, we're putting them in small. So we have a little bit of a window into the future just by understanding those basic properties of trees. So let's jump into redlining. I apologize, the slide looks a little bit like a NASCAR with all the logos, but it really was a team effort. And I want to acknowledge my collaborators. I was working on this research when I was a postdoc at Succinct with when Dr. Hoover was there as well. So redlining can actually be a talk unto itself. Sometimes I do a full hour-long talk on redlining, but here, just to keep it brief, I want to be very clear that race-based zoning and policies and practices came way before redlining, happened during redlining, and have persisted after redlining. From a research perspective, redlining has gained a lot of attention recently because it captures a moment very clearly. It was consistent. So local realtors, real estate agents, planners, all different actors in the sort of urban scene were giving ratings, giving information that went to a rating system to help describe where the federal housing authority would give loans and where they wouldn't. So it was consistent. It has a racial component. It's spatial. And so through the magic of GIS, we can overlay it and augment it with other spatial data. It was applied at the same time. So coming out of the New Deal, the basic idea was deciding where to give home loans based on what was deemed to be the safest, which may have been a worthy goal, but I'll explain in a few moments why it really undercut the access to capital and intergenerational wealth accumulation in some communities and not other. So, and it was also widespread. The 239 largest metros in the country were mapped in this way. So again, to repeat, there was race-based zoning policies and practices before, during, and after redlining. But from a research perspective, it has at least these 5 characteristics that make it very attractive for capturing a moment of time. So the largest cities were cut up into these maps. Redlining gets its name from quite literally on the map. These neighborhoods were color-coded in red and deemed hazardous. And so let me read from a text description of this map. So this is Baltimore. This is Druid Hill Park, designed by Frederick Law Olmsted, who also did Central Park, Prospect Park, many other famous parks. So this yellow neighborhood, it says location, I'll just read from the description, quote, an old residential section seriously threatened with Negro encroachments. A small section of Reisterstown Road consists of fairly modern 2-story brick rows, that's short for row homes, mixed, some Negroes, some owners of long-standing, still occupying old residences, converted apartments containing white-collar, class, skilled mechanics, etc. And then it describes the population according to the 1930 census. Favorable features, Druid Hill Park and good transportation. Detrimental features, obsolescence and Negro encroachment. So again, those are their words, not mine, but you can see the characteristics used to create these neighborhood classifications take into account the age and type of the building stock, the racial and demographic makeup of the inhabitants, the types of occupations that people worked. And the green areas were almost exclusively single-family detached residential areas, US-born white families, so not immigrants. And those are the areas where home loans were granted, and less in B, and then fewer in C, and almost none in D. So some national numbers of redlining from 1935 to 1950, 2.75 million loans were insured by the Federal Housing Authority. Less than 2% of those went to African Americans, about half of which were part of a military program. At that same time, African Americans represented about 10% of the US population. So the odds of receiving this type of loan were 1/5 of their white counterparts. So we can think about intergenerational wealth accumulation and the idea of building wealth through home ownership. That avenue was declined for some people and not others. So there's a wealth of research on redlining across social disciplines and different social sciences. What they consistently find is we have high poverty, high unemployment, low educational attainment, poor health, credit scores, and so on. On the map is a right of Baltimore again. Each of those black dots is a vacancy, either a vacant lot or a vacant building. That's actually a surprisingly difficult map to create. How do you find vacant buildings? Is it those not receiving mail from the US Postal Service? Is it delinquent taxes? It's actually a hard number to get, but we think we have in Baltimore, and it's a moving target, about 15,000 vacant lots and an additional 15,000 vacant buildings. And what you can see is the overwhelming preponderance of correspondence between vacancy today and those neighborhoods that were systematically disinvested in the 1930s and 40s. And so it's no surprise that we see differences in economic indicators, health, and many other factors. So I was interested in environmental things. What about tree canopy? I already mentioned trees provide a number of benefits or ecosystem services, and we know that that distribution is uneven. So we know that it's hotter in the summer where there's less trees, and I'll get to it more later, but those are often lower income communities who therefore have less access to air conditioning. So as Doug was mentioning in the introduction, the brunt of climate change is being borne in some communities much more than others, which is related to the distribution of tree canopy. So we reasoned that larger single-family residential homes have more space for trees, then we would expect more tree canopy in A than in D. Again, access to power is another plausible explanation for why we would see greater tree canopy in A than in D. As part of the Baltimore ecosystem study, where I've done a lot of my research, a lot of legal scholars, historians, and anthropologists have very clearly and carefully documented the ways in which street trees were requested in high-income neighborhoods and in fact were planted, the way that parks and open space were created and maintained in higher income communities, but not in lower income communities and so on. So there's multiple ways that would explain that same outcome, multiple destinations to the same path. So we wanted to see, because we know that the location and allocation of trees and green space in Baltimore is well explained by these mechanisms, we wanted to see if that pattern applied in other metros. The homeowners loan.
Dr. Locke, we have a question in the chat from Professor Jacob Sheff. He asks, by power, are you talking about political power or just electrical power hookups?
Political power. So very much able to garner investment in some neighborhoods. Friends of friends who work in city government and that kind of thing. So the Homeowners Loan Corporation did the redlining. The Mapping and Equality Project at the University of Richmond has done a fantastic job of digitizing, geo-rectifying, and making these data available in multiple spatial formats. So here's Los Angeles. You can see on their web map a quick breakdown of the number and percent of the neighborhoods by grade, demographics. You can get this scanned paper map to overlay. They also have polygons, multiple file formats, and also text descriptions, much like the one I read previously. So in my study, we looked at 37 cities because we looked at all the cities at the time that had been digitized. And since then, University of Richmond has added more metros to that map for public consumption. And then all the high resolution tree canopy maps I could find. And so for some of our larger metros on the left, we had enough data to do within city analysis, and I'll show that in a moment. But for all of the cities, we could do this cross-site analysis of A to B to C to D, looking at average tree canopy. And so I've highlighted Charlotte over here on the right tail of the distribution. A lot of attention goes to our LA, Chicago, Philadelphia, these large cities, but Charlotte, given its geographic and population size, is actually more similar to many other cities and metro areas in the US. So it's arguably more representative than some of the cities that seem to grab the headlines or get more attention in research. High resolution tree canopy. This could be a talk unto itself. This is a map from Los Angeles County. It's a 6-inch map, so very high resolution. This is sort of the standard land cover map that the University of Vermont creates. Now there's a whole cottage industry in academia. Doug's created a number of quality maps, and a number of universities and private firms are creating maps similar to this. This is the southwest corner of Central Park in New York City. And this is just to explain a little bit about how the tree canopy map is derived. So we've got this high quality imagery. Using the false color, we can assign green to the red channel. And that helps the vegetation pop out. We can clearly see grass, shrub, vegetation in that way. We use data called LiDAR, which is a funky acronym for light detection and ranging. So with radar, we bounce a radio wave and see how long it takes to come back, and so we can get the distance. With sonar, we broadcast sound and see how long it takes to come back, and so we can get the distance. And with LiDAR, in this case, we have a plane emitting a laser that's collecting a bunch of GPS points that have their lap, their long, and also their elevation. And so we can create a surface like that. And that's really important. For example, zooming just slightly north, this is still Central Park to your east. In the shadows, in the imagery, is a bunch of tree canopy that's hiding. And because imagery is a passive sensor, the sun hits the earth, that energy bounces into the camera. And so we're missing what's in the shadows. LiDAR, on the other hand, because we're emitting our own light source, is an active sensor. And so that lets us see through the urban canyons and shadows. And so some of the pulses hit the top of the trees, some hit the branches, and some make it all the way to the ground. And so what used to be hiding in the shadows, if we rotate that image in LiDAR, because we have this very detailed lat long and elevation point cloud, what used to be obscured pops out a little bit easier. And here's another view. This is now looking south. This is Columbus Circle that we were just looking at before. So we can take that and combine that with the imagery and say, you're green and you're tall and you're rough, because with LiDAR hitting a building, it's tall, but it's one pulse, one return, whereas with tree canopy, some hits the crown and some the branches and some to the ground. So you're tall and you're rough and you're green, you're now a candidate tree. And so we can iteratively build context and pull out the tree canopy, and using other contextual information, arrive at that 7-class land cover data set I was just talking about. So we can summarize that, and we've used this in a number of research projects. It can also be used for hydrologic modeling, number of applications I won't get into, but onto the analysis. So model 1 is comparing redlining A to B to C to D, but that ignores variation across city, which is captured in model 2. So are there differences in Tampa to Seattle, from Chicago to Los Angeles? Yes, we can confirm that. We don't just assume that. So I want you to focus your attention on model 3. So on average, formerly A-graded neighborhoods, which were single-family detached homes, have about 43% tree canopy today. And their red line counterparts have 21 percentage points less, or about half as much tree canopy today. If you're new to the urban and community forestry space, and you see me saying this is statistically significant, it's beyond the realm of chance alone, but is it really meaningful? Absolutely. So imagine it's a rainy day and you have 43% of an umbrella. Now I want you to imagine it's a rainy day and you have 23% of an umbrella. It's a big deal. And we know from a heat island perspective that around 30 to 35% is where the benefits of tree canopy really accrue in terms of fighting heat island. We know that as watersheds urbanize, 40% 40% canopy and below is when water becomes impaired. And as I mentioned on that bandwagon slide, many municipal initiatives are striving to get to 40% tree canopy. So these A-graded neighborhoods meet or exceed that policy threshold, and their red line counterparts have quite a ways to go. So this matters for heat island, it matters for policy, it matters for water quality. This is a large non-chance difference. Zooming in on some of the largest cities, we can see a rank order of tree canopy from A to B to C to D. There's an exception here in Seattle. I called up some colleagues. What's going on over here? Those two neighborhoods used to be docks for shipping, and now they are well-loved waterfront parks. These have been converted to public open spaces, which explains those apparently aberrant points. I thought I would just drill down on Charlotte, since it was in the full sample for this talk. And on the left, you see Charlotte, and on the right, you see Chicago, the biggest city in the sample. And you see this rank ordering. Recently, there was a review paper of redlining research looking at the environmental determinants of health. And to quote the discussion section of this meta-analysis, it says, quote, "The vast majority of studies found evidence of an association between redlining and poorer outcomes. Selected effect estimates and confidence intervals reported in table 1, sorry about that. Many studies reported an association on a gradient such that each grade moving from A to D had a higher risk for the adverse outcome suggesting a dose-response relationship between poor grade and an adverse impact. Only one study on healthy food access found evidence that redlining was associated with a better outcome, which the authors attributed may be attributable to present-day gentrification. So redlining, the causal impact has been debated extensively. What I think is very clear and not debatable is the lock-in. There was disparities before redlining, and redlining made that more apparent and codified so those patterns could continue. So that was redlining. Sometimes I talk about redlining for a full hour, but let's talk about the present. So redlining is one possible causal mechanism in uneven distribution of tree canopy today. Let's talk about uneven distribution in tree canopy today. This is a study I had nothing to do with. I just wanted to highlight some of my colleagues who flipped the money grows on trees around, and trees grow on money. That old saying flipped around. So they looked at a number of cities, and the key point here is that hot, dry, wet, cold, different growing seasons, things like that. And they did their analysis at two different scales. And because they have high resolution land cover, we can put any boundary. So any zip code or block group or census, any watershed, any polygon boundary in a GIS, we can summarize the amount and percent area of tree canopy or impervious surface or anything else. So within each city, they looked at the census block group. So quick primer on census geographies. Block is the smallest. Block groups, as the name implies, are groups of blocks. And then tracts are groups of block groups. So they conducted their analysis at the block group scale. So there's many of them and they're small, as well as at the tract scale. So there's fewer of them because they're larger. And in every single city, they found a positive correlation between tree canopy and median household income at both scales. One of the most clear and consistent findings. When we look at race and ethnicity, it's a little bit more checkered. It's more nuanced, but there's still a pretty clear signal as well. There's two other recent meta-analyses I want to draw attention to. So these authors went and looked for all the comparable papers they could on income and tree canopy cover and race and tree canopy cover. And again, higher income areas have more tree canopy, and the predominantly white communities are those with more tree canopy as well. The second is a little bit more nuanced, depending on how race is operationalized and different histories of those cities, but the signal is pretty clear as well. So because of all these high resolution land cover maps and urban tree canopy assessments and goals, one of the things that we've found in many cities is that most of the land is private residential, most of the tree canopy is on private residential land, and most of the opportunities for additional greening are also on private residential land. So we wanted to look at where free trees were going. And this is the result of a cluster analysis called geodemographic segmentation. I could talk more about that, but the important thing here is that these categories are arrayed from lowest income on the left to highest income on the right. The green line is the percent tree canopy on residential lands only. The dotted line is the percent of land that's available space, non-road, non-building, non-water, non-existing tree. So that leaves you with grass, shrub, bare soil, and impervious surfaces like parking lots. We looked at a couple of different tree programs. The first, District Department of the Environment and Casey Trees Plant the Tree For You. I'll show in a second that in the triangle, it's a rebate program, so they do it for you versus do-it-yourselfers. And the way you read this graph is each of these dots corresponds to the left, and it's an odds ratio. So if 20% of the population was in senior styles, mostly retirees and older folks, 20% was in this group, and they got 20% of the trees. 20 divided by 20 is 1. So that would be completely equitably distributed with respect to the population in those segments. If 20% of the population got 40% of the stuff, they'd have an odds ratio of 2, 40 divided by 20. If 20% of the population got 10% of the stuff, we'd be at 0.5. And so what we can see is the highest income communities that have the most tree canopy already are 5 to 6 times more likely to participate in the free tree program. So thinking about the future tree canopy, where are the trees being planted today? And so this was done in close collaboration. We've done this in DC, Baltimore, Philadelphia, New York, and it's sorely needed for an update. But just to say, the idea was residential areas have lots of opportunity for trees. Low-income areas have less tree canopy. Let's make trees free. And what we found is that the outreach strategies were very effective in these areas, and they need to develop strategies in other areas, is a clear take home from this. Analyzing a different tree giveaway program. This is for street trees in New Haven, Connecticut. We surveyed people over a 5-year period. The #1 reason for requesting a tree was to replace one that had died or been removed. So if you don't have a tree, how can you have a tree replaced? So we've already seen the disparities from redlining, and we've already seen them by socioeconomic strata. And now we're seeing the participation in tree planting is different by different socioeconomic groups. And now you can see a positive feedback loop. If you don't have a tree, and the #1 reason for requesting a tree is to replace a tree, you can think forward about what the future of the urban forest might look like. So the future, of course, is speculation, continuing with this cliche of past, present, and future. Here's a tree canopy change study I worked on part of coastal Los Angeles, using those market segments I showed for DC a moment ago. And we analyzed a tree canopy map from 2009 to 2014, so a 5-year period. And this map had loss, persistence, and gain. And what we found is that the higher income neighborhoods, again, high income on top, lower income on bottom, had more tree canopy. The portion of their tree canopy that was persistent, so it wasn't a loss or gain, but remained over that half-decade period, was greater in higher income areas. And the net change, those higher income areas were more likely to lose less. So you have more, keep more, lose less. And I would say it's a real research frontier right now. Now that these high resolution land cover maps have been available for about 10 years, cities are now being mapped for a second, in some case, a third time. One of the things we're finding with that is on a citywide scale, you might only have a 1 or 2 percentage point net change. So you went down by 1%. But I like to think about it as a restaurant that's full. So if it's from 5 o'clock to 10 o'clock at night, let's say the restaurant's at 95% capacity. In those hours, parties are leaving and new parties are coming. So the people sitting at each table is turning over. And so when we analyze within the city, we see areas that are losing and areas that are gaining. And so the overall net figure of a 1% increase or 1% decrease masks the very changes that Doug was explaining in the introduction. So a recent paper looking at Philadelphia that showed low-income areas are losing more tree canopy. So there's a disparity in tree canopy cover, and it looks like that gap is actually growing over time. And some of my work on tree canopy giveaways and requests for trees might explain part of that mechanism. Back to Baltimore, back to redlining, because why not? This study, we're using the street tree census, which is a new data set. It's publicly available. They hired the data resources group to collect all the street tree species and condition and other information. We cut up the city into these equal hexagonal grid cells so we could ensure equal sampling areas. This was led by Karen Berghardt, University of Maryland. It was just accepted. She's an ecologist by training. We used a species accumulation curve. So let me walk you through this graph. If you march through the data set, and let's say the first two trees, red maple, on the horizontal axis, we have 2, because we had 2 red maples, or excuse me, 2 data points. And on the vertical axis would be 1. We only have 1 species. Then let's say that the third tree was a white oak, red maple, white oak. Now we are 3 on the horizontal axis and 2 on the vertical axis. We have 3 trees, 2 species. And as you march through the data set, you accumulate more species. And the idea here is when those curves become flat, you've saturated all the species you're likely to find. This comes out of island biogeography and landscape ecology. There's a couple of assumptions and some mathematics behind it. But the reason we used it was to see if the species diversity was different by A, B, C, and D. And what you can see here is that the A and B communities have higher species richness than their C and D counterparts. And the reason that's important is because if you have more species diversity, you're more resilient against the change in climate, pathogens, and pests. So if you had all red maples and Asian longhorn beetle came through, which is a bug that attacks maple trees, it's going to go from maple to maple to maple unchecked. But if you have mixed species, it's harder for that beetle to spread. Same with Dutch elm's disease, same with emerald ash borer, spotted lanternfly, and on and on and on and on. So I've showed with the redlining research before that we see greater tree canopy in A than in D. Now, when we're looking at the street tree communities, we're finding greater species diversity in A and B than in their C and D counterparts. So greater resilience to a changing climate, urban forest pathogens, and so on. And instead of using the number of species, ecologists debate about this. Should we really be using a species diversity index? And so we did it 3 different ways, and the findings were the same. So we see greater diversity in A than in their C and D counterparts. I apologize, this is a bit busy. I want you to focus on Roman numeral 2 here, large trees. So trees greater than 20 inches in diameter, 4.5 feet off the ground. What we see is in the A-graded communities, they are larger trees. So these are more likely to have been planted during redlining than in their D counterparts. We see very few large trees in their D counterparts. I realize that size is not a perfect proxy for age, especially in an urban area. We see these really old street trees that are like bonsai trees. It's like they've been there forever, but they have such poor growing conditions, they haven't realized their full potential. That's why we use just the really big ones. Conversely, looking in Roman numeral 4, really small trees, those that definitely were just planted in the last couple growing seasons, we see statistically significantly more small trees in D than in A. And this is because our planting partners who've seen the early environmental justice research of more canopy in higher income areas sought to put trees in lower income areas. So this, I think, is the signal of trying to flip that. So what's the future of the urban forest? Are all of these really big trees going to die of old age? Is the uneven urban forest going to be flipped in the future? It's possible. I don't think so, because the street trees are only one part of the urban forest. It's not trees on private land, which is the most of the tree canopy in urban areas. And it's not trees on public spaces like parks and open space. So we can't speculate. I don't have a crystal ball, but this might suggest sort of an evening out over a very long time horizon. So that's a little bit about past, present, and future. And While I have your attention, I just want to highlight some ongoing research. So sort of my future directions. This essay came out a few years ago and received a lot of attention, and for really good reason. Chris Schell and colleagues put forward a number of hypotheses related to redlining. And basically they proposed that if tree canopy and parks and open space have an unequal distribution as shown in A, based on redlining. So as I've shown and other researchers have shown, tree canopy by redlining. We might also have different traits in the species. What about species richness? Do we have more biodiversity in A than in D? So kind of related to street trees, but looking not just at plants, but other organisms. And then really pushing, I thought this was so thought-provoking. If urban vegetation is sort of the base of the food chain or the template, and then the insects, and the birds eat the insects, we might have entirely different food webs. We might have entirely different ecologies in our urban areas, in part because of the legacy of redlining. So a lot of attention on this paper for good reason. I've been working with two doctoral students, one in ecology and evolutionary biology at Yale, and another student at Berkeley. And we use the Global Biodiversity Information Facility, or GBIF. So this is an aggregator of citizen science data. So they take an iNaturalist, eBird, some of these platforms for volunteer geographic information. People can go out and collect data on their own and upload them. So we downloaded about 10 million points in about 10,000 whole neighborhoods, almost 200 cities. And this is the outcome of a regression analysis that controls for the greenness with NDVI, or normalized vegetation difference index, the percentage of protected open space within those whole neighborhoods, and population density. And what you can see is the sampling density is significantly greater in A than in D. Not that the biodiversity is greater, but there's more effort in collecting data about biodiversity in an A than in D. So one of the implications of this is a lot of times species distribution models. So this is like if you go birding and you open up and there's a map and it shows you where it's plausible to find a species. A lot of those species distribution models are scientists collecting data, and they go into a spatial distribution model. When they're using citizen science or volunteer data, if they don't have enough data in that area because the sampling density or predicted completeness hasn't reached a certain threshold, it's discounted, it's not included. Only campaigns from scientists and museum collections that meet a certain standard or rigor are being included. So our understanding of the spatial distribution of urban biodiversity is completely skewed towards A rather than D, even though those species are in fact found and counted. And it raises the question of whose data is good enough and access and all kinds of other questions. But what we're finding is more attention is being paid to ongoing biodiversity efforts in A than in D. And a knock-on implication of that is we might be completely missing ecological communities, again, on this sort of dose response curve. This is predicted completeness. I don't have time to get into that. So I just want to thank everybody for your attention. I've shared with you some of the research I've been fortunate to work on with my colleagues and highlight how redlining is related to tree canopy, the consistent finding of inequitable tree canopy distribution today through a number of independent research teams using different data sets across different climates are continuously finding the same thing. And then I've talked a little bit about how planting programs are working and some of the research we've done that maybe blurs on this program evaluation line to give a flavor of what the trends might be in the future. And so with that, again, thanks for your attention. Thanks to both the Department of Geography and Earth Sciences and CAGES for the invitation. And I look forward to answering some questions. Thank you.
Awesome. Thank you so much. Online round of applause for Dr. Locke. What an excellent presentation, and so thorough. And I think really connecting, the kind of urban ecology side, planning, human geography, physical geography, and we do have quite a few questions for you that have come in throughout the presentation and the chat. And so one of the first ones that came in was a question that reads, what kinds of policy changes have you seen that respond to urban canopy loss? So beyond the planting programs that you mentioned, and can you give any examples of those that you think may have been more or less effective in or from an environmental justice perspective? Or maybe approaches that haven't been tried that could hold promise?
Yeah, that's great. Thank you. Tree ordinances have been around long before high resolution urban remote sensing. And we've seen that being strengthened with these tree canopy maps. So more tree protections, and then there can be sort of a battle between developers, and especially in cities that have a lot of vacancy, where the city is very keen on trying to encourage real estate development. And sometimes that can come with the conflicting value of removing trees, these volunteered trees, often on vacant lots, but even on lots that aren't necessarily vacant. So a lot of policies about tree ordinances protecting existing trees, which are being implemented in a variety of different ways, and then the permitting process for construction and development. And related to that, we see like mitigation funds. So if a developer is adding impervious surface, they have to remove impervious surface in other places. Sometimes that can mean green infrastructure without trees. Sometimes that can mean green infrastructure that includes trees, larger retention basins, or enhanced tree pits designed with a very big well for trees. So those are some of the programs. Is there a follow-up question on that, or did I cover that?
Yeah, no, I think, in terms of examples of effective programs or approaches, particularly addressing environmental justice concerns.
Yeah, I mean, fundamentally, future tree canopy is today's canopy, and this isn't my idea. Lully and Bond in the early 2000s put this idea out. Tree canopy today plus gains. So how do you get gains? Grow out of trees and adding new trees from planting, and allowing succession to occur in some environments. Minus losses. Well, how do losses occur? Storm damage, death, removals. And so each of those aspects, you can't count on your future tree canopy. Protect the existing, allow for the grow out, prevent the removal. And so those are the strategies. How that gets implemented tends to be ordinances, mitigation, funds like that.
Pulling another question, and I think this is a great question because it also connects to, you'd mentioned green infrastructure and possible solutions. And so the individual asks, how can we improve the tree canopy in D regions or neighborhoods when A and B are more likely to get new trees even today? And maybe you could, connect this to the observation of seeing some of those smaller trees in D neighborhoods, and whether that's a part of gentrification or maybe that's, how that may be connected.
Yeah, so in many cities, I work DC, Baltimore, Philly, New York, New Haven, Boston, mostly. I did share some other cross-site research today. About half those cities say street trees are in public property. We're gonna fill every available street tree opportunity, no matter what. The other half of the cities say, if people don't request them, we're not gonna plant them because people are vandalizing and removing them. legally, they belong to the city, but in terms of ownership in the more the not legal sense, but somebody can take care of something that they don't own and steward. So about half the cities are like, we're going to do it no matter what. You don't get a say where the bus stop goes. You don't get a say when we installed the fire hydrant. Cities are, trees are infrastructure. We're filling every available tree opportunity. The other half of the cities say, well, we've got a backlog of requests, so we're going to go there first. And people who don't request, we're not going to get there. So that's going to affect what the future looks like. In Baltimore, I shared, there are a lot of small trees being planted in formerly D neighborhoods. But street trees aren't the whole universe. Trees on private residential land are a big part, and trees in public spaces are a big part. And I don't want to live in a world where, every baseball diamond becomes a forest, right? And you keep in mind that we like our parks and open spaces for other reasons too. So there is a lot more attention trying to get trees in lower income neighborhoods. Giveaways is one approach. I shared some now outdated research. Some of the organizations have tweaked their approaches. But then you mentioned gentrification, Dr. Hoover, and I see improvements in cities like bike paths being described as white paths. Green gentrification is very much a thing. It's a very active research frontier. It has some thorny methodological issues, and you're working on it yourself, so but a lot of times these investments are part of gentrification. I mentioned, I think on my second slide, groups are touting that trees increase property values. Well, for renters, that's not such a great prospect. So there's sort of competing values, I think, with any kind of land use planning. There are multiple competing values, and so it might be benefiting to reduce flooding with stormwater capture, and reducing the lethality of urban heat might come at the cost of other things. And it's not that those things are unimportant. They are extremely important. And they actually need a lot more research to understand those dynamics.
Yeah, and I appreciate, I think you bring up a great point, right? Thinking about some of the negative impacts, like increasing in rent prices, right? Which Charlotte, we all know, is and has been for quite some time, growing and increasingly becoming less affordable, on top of just the home purchasing prices as well. So, going off of that, there's another question in the chat. Professor Gagne asks, has anyone looked at the public and private tree canopy cover separately across Hulk neighborhoods, or is that, potential work that you're interested in exploring?
That's a great question. I haven't seen that. And it's somewhat ironic because for so long we've been saying public versus private. Now that we've got these great high resolution land cover maps, we can distinguish between owners. And then the first thing I did was summarize the tree canopy in Hulk without distinguishing. So that is a great question. I thought that name looked familiar. I've seen some of your work. So great question, definitely a frontier and an opportunity. I should mention with the 37 city red line data, we made all that underlying data freely available. So that might save some processing steps if you're interested in a public versus private. A lot of that data wrangling has been done, and I hope that the next person doesn't have to reinvent the wheel on that. So that helps. But that's a great opportunity. And the other thing that's missed, and I quoted from a recent meta-analysis of environmental determinants of health and redlining, and that was really informative. It came out just like 3 weeks ago. Some papers are analyzing the non-rated areas. So we have A, B, C, D, and then there are the areas that weren't graded at all. So they weren't residential in the 1930s, or they were residential of a low density that they weren't graded. And so that's sort of a space for time stand-in of like other land. It sort of conflates other land uses and history of residential development. And so not only do we need to look at different land uses within a Hulk polygon, but also we should accompany the Hulk polygons with this not graded category for further insights about whatever we're looking at.
Interesting. Yeah, I hadn't even thought about the neighborhoods that were excluded and are now a part of the city, right? Or zoning has changed. Well, I want to be respectful of everyone who's in the audience watching and your time. I'm going to go ahead and stop the recording now.